Hey there, fellow explorers. Welcome to another exciting journey into the world of space and volume. Have you ever wondered how much space something takes up? That's called volume. It's a fascinating concept that helps us understand the world around us. Imagine a giant box you could fill with anything. That's three-dimensional space. Think about all the things you could fit in there. We measure volume in cool units like cubic centimeters for small stuff, like tiny toys or even grains of rice. And for bigger things like furniture or rooms, we use cubic meters. It's amazing how these measurements help us in everyday life. Ever heard of a liter? That's for liquids. From your favorite drink to the water in a swimming pool, liters help us measure them all. Now, let's build a box. This will help us understand volume even better. Say it's 2 meters long, 3 meters wide, and 2 meters high. These dimensions are crucial for our calculation. The formula is simple. Volume equals length times width times height. It's a straightforward way to find out how much space our box takes up. So 2 meters times 3 meters times 2 meters equals 12 cubic meters. That's a lot of space. Our box has a volume of 12 cubic meters. Imagine all the things you could store in there. But wait, there's more. Volume isn't just for boxes. We can find the volume of cylinders like cans using a different formula. It's all about the shape. And spheres, like basketballs, have their own unique way of measuring volume. It's a whole new adventure in math. But those are stories for another time. Stay curious and keep exploring the wonders of space and volume. Have you ever held a bowling ball and a beach ball that are the same size? It's quite an interesting experience. They take up the same space, but the bowling ball feels way heavier. That's because of density. Density is a measure of how much mass is contained in a given volume. Density tells us how much stuff or mass is packed into a certain space or volume. The more mass in a given volume, the higher the density. We measure density in grams per cubic centimeter or kilograms per cubic meter. These units help us understand and compare the densities of different materials. To calculate density, we use this formula. Density equals mass divided by volume. This simple formula helps us determine how dense an object is. Imagine a brick with a mass of 2 kilograms and a volume of 1,000 cubic centimeters. This brick is a perfect example to understand density. Its density would be 2 kilograms divided by 1,000 cubic centimeters, which equals 0.002 kilograms per cubic centimeter. This means the brick is quite dense. Density helps us understand why some things float and others sink. For example, a dense object like a stone will sink in water, while a less dense object like a piece of wood will float. It's all about how tightly packed those molecules are. The tighter the molecules are packed, the denser the material becomes. This concept is fundamental in understanding the physical properties of materials around us. Ready, set, go. The thrill of the race begins. We've all gone fast, whether on a bike or a roller coaster, the wind rushing past, the adrenaline pumping. But how do we measure how fast we're going? It's not just about feeling the speed, that's where speed comes in. Scientists and engineers use precise tools to measure it. Speed tells us how far we travel over a certain amount of time. Imagine running a race and knowing exactly how fast you went. We use units like meters per second or kilometers per hour. Driving on the highway, you might be going 100 kilometers per hour. Cars zoom past, each one adhering to speed limits to ensure safety. The formula for speed is simple yet powerful. Speed equals distance divided by time. This formula helps us understand motion in a quantifiable way. Let's say you biked 10 kilometers in 1 hour. That's a good pace for a casual ride. Your speed would be 10 kilometers divided by 1 hour, which is straightforward to calculate, which equals 10 kilometers per hour. Speed is relative too. What feels fast to one might be slow to another. A snail might be slow to us, taking its time to move just a few inches, but it's super fast compared to a tree. Trees sway gently, barely moving from their spot. From the fastest jets to the slowest snails, speed is all around us, shaping our world in fascinating ways. Section 4. Area Adventures, Flat Out Fun.
Imagine you're painting a wall. Area tells you how much paint you'll need to cover that flat surface. We measure area in square units like square centimeters or square meters. Let's say your wall is 4 meters long and 3 meters high. The formula for the area of a rectangle is area equals length times width. So 4 meters times 3 meters equals 12 square meters. You'll need enough paint for 12 square meters. Area helps us measure all sorts of flat surfaces.
So there you have it. We've explored volume, density, speed, and area, all important concepts in our everyday lives. Keep your eyes peeled and you'll start to see them everywhere. Remember, science is all about exploring and asking questions. Now go out there and have fun measuring the world around you.